Hello, welcome back, student. Today we are going to start the next topic in the unit 2, the chapter 2. Okay, so first we will see what we have seen in the last class. In the last class, we saw the analysis of quick sort and we saw the merge sort. These two things we saw in the last class. In today's lecture, we are going to start the next method, that is greedy method. In the previous method was a divide and conquer method. Okay, now we are going to learn the greedy method. What is greedy method and what kind of problem we can solve in the greedy method. And second one is feasible solution. What is feasible solution? We will see that. And we will see what is optimal solution, because this is one of the important part in the greedy method. And objective function, this is the objective function. These three are most important in the greedy method. Okay, and the next one is minimum cost spanning tree. This is one of the method in the greedy method. So this in greedy method we will solve this problem. Okay, let's move. Greedy method. In the greedy method, what is greedy method? In the name itself you can see it has more greedy. That means among all the algorithm approaches, the simplest and straightforward approach is a greedy method. Okay, what is greedy method? From different means all algorithm approaches, which one is the simplest and straightforward approach is a greedy method. In this approach, the decision is taken on the basis of current available information. Whatever the information you have currently, based on that it will take the decision without worrying about effect of current decision in future. Means whatever the decision you are taking, that should not without worrying about the future. Okay, whatever the decision you are taking, that is based on the current situation. Greedy method. Okay, without without worrying about future. This is a greedy method. So what kind of problem you can solve with the greedy method? First, knapsack problem. This is one of the problem that you can solve with the greedy method. Optimal solution, optimal storage on tape. This is one of the problem that also you can solve with the greedy method. Job sequence with deadline. So every job will give the deadline. Within that, it should complete the job. That is also one type of problem that also can solve with the help of greedy method. And optimal merge pattern, minimum spanning tree or minimum cost spanning tree, single source shortest path. This all are the things, all problems can be solved with the greedy method, and this all are in your syllabus. Okay, knapsack problem, optimal storage on tape, job sequence with deadline, optimal merge pattern, minimum cost spanning tree, single source shortest path. Okay, this all are the problems will come under in greedy method, and this all we will solve one by one. Okay, so today we are going to see minimum cost spanning tree. Okay, so before going to the minimum spanning tree, first we will see what is feasible solution. Feasible solution is a solution set of values for the decision variable for which all of the constraint in the linear programming problem are satisfied is called a feasible solution. What does it mean? This means feasible solution is like if you like whatever the condition, like example, uh, if you are going to the college, okay, so you will have the, like, there will be a condition, there will be a constraint, means you should go from the Chandran Gutta. Okay, if you want to go from Charminar to ISL Engineering College, so you must reach, means you have to come from the Chandran Gutta. So this is a constraint. So you need to come from the Chandran Gutta, and every bike or car has a different time. Okay, so based on that, if it is satisfied, everyone is going to Chandranguta and coming, someone is coming on by bus, someone is coming by car, someone is coming on bike, okay, but everyone is reaching to the ISL Engineering College. So that is feasible solution, because whatever the constraint we decided, that is, everyone is followed that and reached the destination ISL Engineering College. Okay, so this is a feasible solution. Clear? Now the next one is optimal solution. So optimal solution is a feasible solution, okay, where the objective function reach its maximum or minimum value. For example, the most profit or the least cost. A solution that satisfies all the constraints of a linear programming with high profit or low cost is known as optimal solution. The same thing, feasible solution only, like how the people, how the students are coming from Chandran Gutta, like from Charminar, then it is coming to Chandran Gutta and coming to ISL Engineering College. So in this way, everyone is doing. So that is feasible solution. Someone is coming by bike, on bike, by bus, by car. Okay, but now the what is optimal? Optimal means which one is the best. Means if you are coming on bike, how much time is taking? Okay, so time is less. Then your solution is optimal. Okay, if you are coming by bus, the bus take a lot of time, so that is also, like, that is not a optimal solution. In if you understand, from the feasible solution we need to find the best solution. How will you find the best solution? You should get the high profit or low cost, that is a optimal solution. Okay, I hope you understand. The feasible solution is that it will solve the problem following all the constraint whatever we are applying, like you have to come by this, that, whatever the condition or constraint you are giving to that problem. So if it is solved that, then that is a feasible solution. From the feasible solution we need to find the optimal solution. That's why we are telling an optimal solution is a feasible solution. Why we are telling this? Because we are getting the optimal solution from the feasible solution. Okay, fine. So this is feasible solution and optimal solution. I hope you understand this, because in the all program you need to in this greedy method we need to work on feasible solution and optimal solution. Okay, once again I will explain you. Feasible solution is like if you are solving a problem and it has some constraint is nothing but like conditions. You are applying some condition, you should come from here, okay, you should come on this time, you should come, like whatever the condition you are applying, that is constraint. If it is uh, take that, means all the constraint it is satisfying, okay, then it is a feasible solution. It solve the problem with all the constraint, that is a feasible solution. And from the feasible solution, which one is the best, high profit low cost, or which one is taking minimum time, okay, and maximum profit, based on that we will select the optimal solution. Okay, next, objective function, a function that is used to determine a good solution for optimizing problem is known as objective function. What is objective function? A function that is used to determine a good solution, this is a good solution, for optimizing problem is known as objective function. Okay, so these are the three things are there. Now we will move to the next is minimum cost spanning tree. What is minimum cost spanning tree? A spanning tree is a subset of graph G. The subset of graph G which has all the vertices covered with minimum possible number of edges. Hence, a spanning tree does not have cycle and it cannot be disconnect. Okay. So here we'll see the example, like it should not have a cycle. Okay, it should not have a cycle and it should not be disconnected. Okay, see here, this is a graph, this is a graph, and see, these all are connected. A B A B C. A B C is a vertices, and these lines are edges. Okay, and this all are the minimum spanning tree. Spanning tree. This is a spanning tree. First, we will see the spanning tree. Spanning tree is nothing but it should reach all the vertices A, B, C. It reaching all the vertices with minimum edges A, C, B. Here also it is reaching all vertices. Here also it is reaching all vertices. So this is a spanning tree. Here, this every edge will have the weight, means how much weight from A to B, 10, 9, 4, 3. Okay, I will show you the example also. So here from A to B, how much time is taking? So this is a minimum tree, minimum spanning, sorry, this is a spanning tree. From this we need to identify which one is a minimum. How will you identify? When you have a weight on the edges from A to B, there is edge, there should be a some number. Okay, like see here in this example, every edge 1, 2, 3, 4, these 4 edges are there. Okay, and every edge has some weight, like from here to here 1, here to here is 2. Okay, so here we can consider this is A, this is B, E, and this is C. Okay, from A to B the weight is 1, from B to C is weight is 2, from C to D is weight is 5, from D to A is 4, and from A to C the weight is 3. So this is called undirected graph. What we will say? Undirected graph means there is no direction. We can say it is coming from A to D, or we can say D to A. We can say here A to B or B to A. So this is undirected graph. It is not mentioning any direction. Okay. So this is a graph. From this graph we need to find the minimum cost spanning tree. So to reach all the 4 vertices, okay, A, B, C, D, we need to reach all the 4 vertices. Here it is reaching 1, 2, 3. Okay, and one more thing, remember how many edges are there. Okay, that should be uh, edges means how many vertices are there. Vertices minus 1, that many edges needed. Okay, like here how many vertices are there? 1, 2, 3, 4. How many edges here after making a spanning tree? 1, 2, 3. 1, 2, 3. Okay, so this is a one way we can make the spanning tree, but what will be the cost? 4 plus 5 plus 2, this cost is 11. Okay, is there any possibility? Yes, we have another possibility. You can check here. 4 1 2, 4 plus 1 plus 2. So this is minimum cost spanning tree. And you can take the another, this one is the best solution. So this is a minimum cost spanning tree. We can make the another also, 1, 2 and 3. So 4 plus 3 plus 2, this is 9. So this is also a spanning tree, but not a minimum. So minimum cost spanning tree is this one. Okay, this is our final answer. So this is the minimum cost spanning tree. So what is the advantage? So as we discuss here, it is all in the writing part here. Minimum cost is a minimum weight, all the other of the tree of the same graph. Okay, and what is the real world situation? The weight can be measured as distance. What we are telling here, weight 1, 3, 2, 5. What is this? Like we can say from A is Hyderabad, B is Mumbai. From Hyderabad to Mumbai, there will be a distance. So there, whatever the distance, that is considered as weight. Okay, so the measured as distance, conjunction, traffic load, or any arbitrary value donate to the edge. Okay, whatever you are representing as a edge weight, that is maybe a distance, a traffic load, or anything. Okay, and what is the advantage? Oh, what is the application of minimum cost spanning tree? Minimum spanning tree has direct application in the design of the network. It is used to find airline routes. If it can be used to approximately solve the traveling sales problem, but this application is hardly used. Okay, this is one type of problem, traveling salesman problem. Like a man is sailing from city to city. So that kind of problem also you can solve with the help of greedy method, and you can use the minimum cost spanning tree for that. Okay, for the airline route also it is very important to find the minimum cost spanning tree. Okay, and most of the time we use the minimum cost spanning tree in your real life. Whenever you are going from source to destination, we will find the best solution, which one is a less time taking route. We will select that and we will go on that. Okay, so here, like as I told you here, how many vertices are there? Vertices minus 1 is edge. 1, 2, 3, 4, 5, 6, 7. 7 vertices are there. After solving this, the best solution, minimum cost spanning tree, is 1, 2, 3, 4, 5, 6. 6 edges are there. 7 vertices. Okay. Whenever we have a 7 vertices, you will get the 7 minus 1 is 6 edges. Okay. This is called uh, vertices, and this is called edge. Okay. So here this is a problem. Okay, and this is a answer. A graph and its minimum cost spanning tree. In the minimum cost spanning tree, there is a two algorithms are there. First one is Kruskal algorithm and another one is Prim's algorithm. Kruskal algorithm and Prim's algorithm. They both will find the minimum cost spanning tree only, but it will the approach is different. Okay, approach is different. We will see this. What is Kruskal algorithm? Kruskal algorithm, to find the minimum cost spanning tree, use the greedy approach. Using the greedy approach. This algorithm treated the graph as a forest, and every node it has an individual tree. A tree connected to another only and only if it has the least cost among all available options and does not violate MST property. Minimum cost spanning tree property should not be violated. Okay, it is like a tree. Like if you are getting in the forest, like the tree, there will be a different roots are there. From there, which one is a minimum cost, it will go on it, and that should not be violate the minimum spanning tree properties. So under Kruskal algorithm, we will take the example this. Okay, this is from the source A, B, C, D, and this is final destination. We can say final. Okay, so this is starting from here and terminating here. So you should find the best solution, because you can see here there will be a more possibility from you can reach all the vertices, and there are so many routes. Like example, from S to A to B, here like this, here, here, and here. This is one possibility. The another one is from here to here, S to C, C to A to B, B to D, D to T. This is one, and you can go S to A to C, C to B, B to D, D to E. There are so many possibilities are there. Okay, but we should follow the MST property. Okay, so whenever you have this, the first thing you need to remove all loop and parallel edge. This is called loop. Okay, and this is called parallel edge. So I am removing this and I am removing this. Okay, so when I remove this, so now my graph is like this. Okay, in case of parallel edges, keep the one which is least cost associated and remove all. As I remove this, why I remove this, because I remove this cost is high 9, because of that I remove this one. Okay, and this is a loop. What will be the cost for the loop? You have to remove it. Okay, now we got this. What is our first step? First step is remove all loop and parallel edges from the given problem. If you don't have, no problem. If you have, remove it. Step 2. What is step 2? Arrange all edges in their increasing order of the weight. Increasing order of the weight. The next step is to create a set edge and arrange them in an ascending order. Okay, that means you have to come to the graph. Which one is a minimum weight? 2. Okay, 2. B comma D. What is the cost? 2. Next, 2 is there, yes. D and T. D and T. What is the cost? 2. The same graph here making. BD is 2 and DT is 2. AC. What is AC now? A and C is 3. A and C is the weight is 3. CD is the weight 3. CB is 4. CB कहाँ है? Where is CB? C and B 4. Okay. So how many edges are there? That all the edges we are making in the table in the increasing order, means from lowest to highest. Okay. So when you complete this, here this all is step 2. What is our step 1? Step 1, we need to remove all the loops and parallel edges. In the step 2, arrange all edges in their increasing order of weight. Step 3, add the edge which has the least weightage. Which has the least weightage. Now we are starting according to this table. What is the step 3? According to this, you need to draw. Okay, which one is the minimum? Is 2. B to D, D to T. So this is we draw in this step. Okay, what is the next one? A to C and C to D has the same weight. In the next step, A to C and C to D. These two already we have done here. This A to C and C to D is we have marked dark. Okay, then what is the next one? C to B. C to B is 4. But next cost is table 4 is observe that adding it will create a circuit, the graph. When you are adding this C to B, when you are adding C to B, it is forming a cycle. Already 2 is here, 3 is here. When you make like this, it will make a cycle. So this is MST, minimum spanning tree property is violating. So you should not add this. You should not add this edge because we are forming a cycle. That should not be happen. Okay. So we are removing that. Next, we are ignoring this one. Okay. We are not adding because when you are adding this, like it is making a cycle, and MST property should not have a cycle. B to T. Let's go and check the B to T. B to T. When you are making B to T, the same problem we are getting now. Same problem we are getting when you add here, it will make a cycle. So these two, okay, these two are removed. That means we are ignoring. We are not adding this. When you are adding this, MST property is violating. Okay, we removed. Next, what is the next one now? A to B. A to B. What is A to B? Sorry, here. A to B. When you are making A to B here, that is also making a cycle. Okay. So that also we need to remove. We should not add. Next, SA. SA. S to A is 7. We are adding. When we are adding, we are not getting any kind of problem. Okay. So by adding edge S to A is included all the nodes of the graph, and now we have minimum cost spanning tree. When we add this, our all edges we reach 1, 2, 3, 4, 5, 6. 6 edges we got it. And how many? 6 vertices we reach with 5 edges. 1, 2, 3, 4, 5. Okay. So this is your minimum cost spanning tree MST. Minimum cost spanning tree of a given problem with the help of Kruskal algorithm approach or Kruskal algorithm method. Okay, so this is the one method to find to get the result of Kruskal algorithm. Okay, so what is the first step? Once again I will repeat. First step is remove all loops and parallel edges. In the step 2, arrange all the edges in their increasing order of weight. Okay, according to this, according to the table, we need to add the graph like 1 by 1, 2, 2. If anyone is finding the cycle, you need to remove that edge like C to B, it was making a cycle. So we remove that, B to T and A to B. Okay, so this is the final answer for the Kruskal algorithm. Okay, and this is the whatever we have done there, that is algorithm here. Okay, so here what is the algorithm? E is a set of edge in G graph. Graph has n vertices, cost u comma v. So there will be n vertices. N vertices means we had the 6 vertices the previous example. Cost of edge u comma v. T is the set of edge in the minimum cost spanning tree. The final cost is returned. So here the construct a heap out of the edge cost using heapify for I is equals to 1 to n to parent of I is equals to minus 1. Each vertex in a different set. What is the I over? I is 0, and what is our minimum cost? Minimum cost initially it will be 0. While I less than n minus 1, and heap not empty. If heap is not empty, then do this. Delete a minimum cost edge u comma v from the heap and reheapify using edges. Again we need to reheapify using edges. J is equals to find u, k is equals to find v. Okay. If j does not equal to k, then okay, when j and k, if both are not equal, then I is equals to I plus 1, and t is I comma 1 is equals to u, t I comma 2 is equals to v. Minimum cost is equals to minimum cost plus whatever the cost we are getting with the cost u comma v, and you need to make the union of j comma k. Okay, so this is working when our I less than n minus 1. If I does not equal to I less than 1, then write no spanning tree, else return minimum cost. Okay, so this is a simple algorithm for the Kruskal. Okay, whatever you are taking here, that is E, cost, N and T. E is a set of edges in the minimum cost spanning tree that we used here, and this is a algorithm. In the exam, if it is asked the Kruskal algorithm, you must draw, means you must show the example as well as you need to write the algorithm. Okay, and what is the time complexity? The Kruskal algorithm most time consuming operation is sorted because the total complexity of the disjoint set operation will be order of E log B, edges log vertices, which is the overall time complexity of algorithm. This algorithm is more space consuming. So what will happen in the Kruskal algorithm? Kruskal algorithm is taking more space. As I shown you here, first we have a heap, then again it is reheapifying. So it's need more space. Okay, and what is this? Order of E log V. Okay, so this is Kruskal algorithm. In the next class, we'll see the Prim's algorithm. Okay, thank you very much. We'll see you in the next class with the Prim's algorithm. Okay, thank you very much.